Unit circle. I'm not going to do all of them, but you are. Unit circle. You've done this in Algebra 2 at the end of the year. I'm going to go through and explain how they come up with the numbers so that hopefully that will stick in your mind a little bit better. This is not part of your homework, so you do have to have the answers of the coordinates and stuff. And the best way to learn it is to force yourself to do the work. Okay? So we're going to start with the easiest one, and I'm going to explain where the numbers come from. So first we're going to start with 45 degrees. Let me drop this down.
How big should we make this under paper?
I would make it half, almost half a sheet. If it's okay if you can do it, less than that is fine. Because I'm going to do another one and another one after that. So if you need, take up a third of the sheet. You probably put 3. I wouldn't put more than 4 on a sheet unless you're going to put them side by side. Because we're going to put lots of stuff, and I'm going to keep drawing pictures, and you can either add it to the same picture if you want, or make a new picture. It's up to you. Okay, so if this is 45 degrees and I drop an altitude down here, what's this degree?
45.
45 degrees. If they're both 45, what does that tell you about the legs?
They're equal.
They're equal, so this leg is the same as that leg. Alright, in a unit circle, the radius is 1 unit, so my hypotenuse is 1. In a right triangle, I can use the Pythagorean theorem to figure things out. I want to know what this terminal point is. This is called a terminal point. It's your coordinate. That's what I'm asking for. So in so doing, I want to be able to figure out what x is. So what I'm saying is this piece right here is my x, and if this goes over to the y value, then this is my y value. And you just told me that x and y are the same in a 45, 45, 90 degree triangle, correct?
Yeah.
Okay. So let's see how they come up with this. If you remember algebra, you were taught what a 45, 45, 90 degree triangle was. If not, no big deal. Let's figure it out. X squared plus y squared equals r squared. 2 of the legs squared added together equals the hypotenuse, which is your radius, squared. If x and y are the same, I can rewrite this like this. Make sure you understand what I'm saying before we go on. And if r is 1, 1 squared is 1. Okay. So far so good? Okay. This is 2x squared equals 1. What do I do? Divide by 2. X squared equals 1/2. Take the square root. And sometimes in your book they leave it as 1 over the square root of 2. Square root of 1 is just 1. But most of the time in the book they want you to rationalize the denominator. How do I do that?
Multiply the square root of 2.
Multiply the top and the bottom by the square root of 2. And I get radical 2 over 2. That is what x is. The square root of 2 over 2. And again, you told me that y and x are the same. So y must be the square root of 2 over 2. Alright, so now we're going to start making some leaps here. So this coordinate here is what? The x value, the square root of 2 over 2, and the y value is the square root of 2 over 2. That's your coordinate of this point. This point, the x value is the square root of 2 over 2. The y value is the square root of 2 over 2. Now, watch. that's 45 degrees. What if I said 135 degrees? And here's where it's important to understand what I mean by a reference angle. A reference number. A reference is when we look at how close it is to the x-axis. I don't really care that it's 135 degrees yet. In a minute we'll need to know that, so we can use it. But how close is this to the x-axis? How many degrees? 45. So again, we have a 45 degree, 90 degree triangle. So aren't these legs the same as those legs? Okay, so what is this coordinate? Now be careful, you're in the second quadrant. What is that coordinate?
Negative square root of 2 over 2.
Yeah, this is still radical 2 over 2 and radical 2 over 2, the distance, but this is on the negative side of the x, so it's negative radical 2 over 2 and radical 2 over 2 for my y. So a 135 degree angle, terminal point, has a 45 degree reference. Okay? Reference is the key part to understanding all of the polar coordinates. If you can understand the reference, how close it is to the x-axis, you can easily fill out this chart faster than you can think about it. You just be writing down, you can't write as fast as you can think about it, alright? So tomorrow, your quiz is you're going to fill out this chart. But you're going to be good at it. So right now, you have 45 degrees, you have 135 degrees. What if I said 225 degrees? Well, we are now at 180, and 45 more will be 225 degrees. So again, what's my reference? How close is this to, what's the reference to the x-axis? Isn't that going to be 45 degrees? Yes or no? 225 degrees is 45 degrees past 180 degrees. 180 degrees is a straight line, that's the x-axis. So again, if this is 45 degrees, and I drop down my altitude here, I have a 45 degree triangle again. Well then, again, aren't these two sides the same? Yes?
Yes.
And so their legs are the same as what they've been. So tell me again, what is that terminal point? I'm trying to use the vocabulary they use in the book, because you're going to read this and you're going to be like, okay, what is he talking about? The terminal point, what's the coordinate of this one? Now we're in the third quadrant.
Negative square root of 2 over 2, and then negative square root of 2 over 2.
Yeah, they're both negative in the third quadrant. The distances are still the same. Notice that they're all the same. 45, 135, 225. Alright, so if we keep going, this is 270 plus 45 would be 315 degrees. Again, what is my reference here? To the x-axis. 45 more degrees, right? This is 315 degrees. My reference would be 45 degrees. So again, this makes a 45, 90 degree triangle. The distances are still the same. So what is that terminal point quadrant? What kind of quadrant coordinate? Positive x, negative y. Isn't the 45 degree triangle or the 45 degree references easy to remember? Aren't they? They're all the same, right? Yes or no?
Yes.
I need to know if you're following me or if you're looking at, the space.
Got it.
Okay, 1, 2 of you. Great. So just to kind of shake it up a little bit here, and then we'll do the 30 and the 60 degree ones. We're not done with this yet. Notice it's getting kind of crazy, so if you want to draw another circle, you can. We'll do the 30 and 60 on another spot. Then I want to continue with this for a second. What is this coordinate? What is it? Well, it's 90 degrees, but what's the terminal point? What's the coordinate? 0, 1. 0, x is 0. And if the radius is 1, isn't that 1 right there? Okay, don't get too crazy here. Not all of it's difficult. Okay, what's this one? Yeah, -1, 0. And this one? 0, -1. Good. All right. So tomorrow on your chart, you're going to tell me the degree. You're going to tell me the terminal point, the coordinate, and you're also going to tell me what this is in terms of pi. And this is actually very simple. I'm going to give you a couple different ways to figure it out. So first, let me explain how to come up with this. Theta. You can't even see that.
That's okay.
Draw so you can see it. Okay.
Danny.
Crosshairs aren't very good. All right. Circumference of a circle. What is the formula for the circumference of a circle?
2 pi out.
Yeah. 2 times pi times the radius. Okay, in this case, what is my radius? In a unit circle, the radius is 1. So what is 2 times 1? 2. So in a unit circle, the circumference, the distance around, all the way around this circle, we get to 2 pi. We start at 0 and we end up at 2 pi. And if we go around again, we end up, this will be 4 pi. And again, it'll be 6 pi. And then 8 pi. So multiples of 2. Well, what's the circumference when I only go halfway around? 1 pi. Okay, so you guys remember that stuff. Alright, if that's the case, what is my distance when I stop at 90 degrees?
Half pi.
Half of pi, or we say pi over 2. Now, this is too difficult, isn't it? You got everything that's up here, you have to write on that chart tomorrow. And so far, you're all acting like, okay, this isn't so bad. All right? You've already narrowed down the 45 degrees and their references. 135, 225, 350. Those are all 45 degree references. Remember that word, reference. Okay? So that's, and you're doing really well on the pies. What's this one down here?
1.5.
What?
Pi over 3.
So we're at pi. Aren't we adding pi over 2 to pi?
3 pi.
Yeah, 3 pi over 2. Okay, if you're struggling with what we just said, do it like this. I'm all the way to pi. I'm going to add another 90 degrees, which is pi over 2. This is one way you can do this. I'm going to show you a multiplication way here in a second. We've got to get a common denominator, so multiply by 2 over 2. That's where they get 3 pi over 2. So this is 3 pi over 2. You've got to be able to do this without your chart. Now, when you do your homework, I expect you to have this chart that you're going to make tomorrow out in front of you, because the rest of the chapter you're going to reference this stuff. It'll make it easier. You do not get it on the test.
Didn't you used to have a poster?
Yeah, somebody took it down.
I wonder who.
So, yeah, you're going to have to do it on your own.
Somebody.
Oh, you purposely
Hey,
took
can
it
I
down?
make you one?
Yeah, it's really difficult to Google it,
Oh.
but you can't do it on the test. Okay, and you're going to have this piece of paper in front of you after tomorrow. Yeah.
Is this something we can make as a poster?
Well, everybody's going to have it on a piece of paper. I have a piece of paper for you. This is going to be your quiz tomorrow. Oops.
So
That's your quiz.
So if we mess that up.
Final.
Yeah.
This is easy. Can I go on, please? Okay, So let's slow this down a little bit because the references that we always talk about are always between 0 and 90 degrees. So let's talk about this right here. We did 45 degrees. Isn't 45 half of this? Okay, so if 90 degrees is pi over 2, what is 45 degrees in terms of pi? So how do we do that? You can do pi over 2, and we say half of 90 degrees. Half of pi over 2. Of means multiplication, right? 1/2 of pi over 2 is what? Yeah, pi over 4. So 45 degree, the reference, every time you have if it's asking for the reference, and it comes out to be 45 degrees. If it says you have a 315 degree angle, what's the reference point? The reference point would be pi over 4 because you're 45 degrees from the x-axis. Okay? Here's the other way to do this calculation. 45 degrees times, and memorize it, pi over 180. So you can do it like what we're doing here, or you can do it like this. You'll get the same answer either way. So for instance, we already know that that's pi over 4. 45 and 180 are both divisible by 45 degrees. 45 divided by 45 is 1. 180 divided by 45 is 4. So the answer is pi over 4. You just have to keep reducing until it doesn't reduce anymore. So it's not just the 30, 45, 60, 90 degree angles that you can do. You can do anything. If I said, what's 12 degrees in terms of pi? Okay, that's not a nice, neat thing. So multiply by pi over 180. Well, 12 and 180 reduce by 12, don't they? Pi over 15. So 12 degrees is the reference point would be pi over 15. So this is how you can do it even if you don't know how to do a triangle, right triangle, and figure it out. Okay? So two different ways. You can add and subtract pi's until you get the right thing. Alright, now I want to talk about the 30 and 60 and 90 degree triangles. So on this one, we'll draw it. So this is a 30 degree angle. And if you remember, so that's on my work here. A 30, 60, 90 degree triangle is 1/2 of the hypotenuse. That is your short leg. What's my hypotenuse? It's a unit circle. What's my hypotenuse?
1.
1. So how long is my short leg here? 1/2. So right there, we have our y coordinate of our terminal point. Long leg is the square root of 3 times the short leg. What's the square root of 3 times 1/2?
Square root of 3 over 2.
Square root of 3 over 2. Alright, so this is what you need to remember. First of all, the square root of 3 is bigger than 1. So that should tell you, if you confuse them, that should tell you which one's the long leg. The next thing I want you to notice is this. All of these are divided by 2. Every one of them. The 30, the 60, and the 45. Those are the ones that we're really referencing. Now, there can be some other things. Okay. But the main ones and what you're doing on the chart are all going to be divisible by 2. What you need to realize is whether you have the short leg or the long leg. So this is the square root of 3 over 2. That's the terminal point. Watch how easy the rest of this is. If we go to 60 degrees, so now we're at 60 degrees. Where's my short leg? Because isn't a 60 degree angle just another 30, 60, 90 degree triangle? Yeah. If this is 60, this has to be 30. So it's the exact same thing as this one, but it's backwards. Here's the short leg. So my x is 1/2. What's my y? Square root of 3/2. Okay. Not too bad, is it? Okay, so what if I said this? 120 degrees. 120 degrees. I want to know what this terminal point is. Here's what I want you to think of. What's your reference angle? 60 degrees. Reference meaning, what is this to the x-axis? It's 60 degrees. So if that's the case, this is my long side, this is my short leg. So what is this? Terminal point. Yeah, the x-axis here, the short leg, is going to be negative 1/2 and positive square root of 3/2. Okay, and if I said this, 150 degrees. 150 degree angle, what is my terminal point?
Negative square root of 3/2.
Yeah, this is my long leg, which is negative square root of 3/2 and positive 1/2. And so on and so forth. You just have to watch which one's which and if it's positive or negative. All the way around. You have to do the whole circle all the way around. The tough part is your pi. What is 30 degrees in terms of pi? You could do that, which is pretty simple. What's 30 and 180?
6.
Yeah, 1/6. So this is pi over 6. These are your reference numbers because I'm going to start giving you very large degrees. And we have to do multiples to figure out what your reference point is. Okay? 60 degrees. If you want to do it like this. Isn't 60 the same as 230 degrees? What's 2 times pi over 6? 2 times pi over 6. Pi over 3. Or 60 and 180, that reduces to 1/3 pi over 3. You got to fill all that out, all of this out on the chart tomorrow. The degree, the reference, and the terminal point. Is that it? Yeah, that's it. Not too bad. Right? Okay, that's your quiz tomorrow. Now, what are you doing on your homework? Example 4 in your homework. Is it on the unit circle? You say, well, wait a second, that's not any of the fractions we just got done doing. How do I know if something's on the unit circle? I'm just going to draw it. You don't have to do this. I'm just going to draw it as a reference. What quadrant am I in? Second quadrant. So somewhere over here, I'm dealing with this right here. I want to know, that's my terminal point. I want to know what this, if this is actually on this unit circle or not. If it is, then the hypotenuse is 1, isn't it? And this is a right triangle. And in a right triangle, a squared plus b squared equals c squared. If it doesn't equal, then it's not on the unit circle. So all I have to do is figure out if this is true. X is negative 5/13, y is 12/13. and 1 squared is 1. Everybody do that, please. Tell me if that's correct. What? Finish it up, check it, make sure it's right. So at that point in time, you'd say yes, it's on the unit circle. Alright, so what you should get out of this is that if you square both those out together, it should equal hypotenuse squared or equal 1. Okay, now let's erase some of this stuff. Do some more. Alright, number 10. Point P is x negative 7 over 25. It's in quadrant 4. It's on the unit circle. What does x have to be for it to be on the circle? So first of all, is it positive or negative? And how do you know? How do you know that? Yeah, so somewhere over here, we're in quadrant 4, the x value has to be positive. And again, this is a right triangle. So x squared plus negative 7 over 25 squared has to equal 1 squared. It is on the unit circle, so it does make a right triangle. So use the Pythagorean theorem and solve for x. And when you solve for x, you'll get the value that x has to be. So everybody do that. Algebra at this point. So far everything's easy, right? Everybody's freaking out about tomorrow's quiz. Most of you. Keep trying, don't ever quit. I don't care how lost you are, don't ever stop. You guys are all way too smart for that.
How's it gonna be now? That's 45 stuff instead of like a 60 degrees.
I don't know, I just drew it in the fourth quadrant. So it could be this. I don't know, how do you know that's 45 anyway?
I don't know.
Right there, it's in the fourth quadrant. Okay, there it is.
Will you go through how to do that?
Yeah. X squared plus 49 over 625 equals 1. Subtract that to the other side. 1 is the same thing as 625 over 625. I need a common denominator, so obviously that's what I need to do. What's 625 minus 49? Now what?
624.
I don't know why I was thinking about 4 a minute ago. Okay. What do I do? Square root. With authority. Take a square root, fool. Is that correct? Please check my math. We all know how good I am. No? Did I do it wrong? Is it, since we took the square root, it's positive or negative. So which one is it? Yeah, we already said it was positive. So it's positive 24/5 that goes in for x. So that's how you find a missing piece. All right, and then it gets crazy after that. Example 24. I mean, you got some easy stuff to work on before we get to here. If I say my terminal number is 3 pi over 2, and I want to know what my terminal point is, the coordinate, the first thing you should do is convert this into degrees, unless you know what it is. If you don't know what it is, and they're going to give you lots of different things you got to reference. So here's the easy way to make this into degrees. We all know that pi is 180 degrees. So what's 180 divided by 2? You could take 180 times 3 and then divide by 2. You could take 3 divided by 2 and then multiply by 180. It doesn't matter. You're going to get the same thing. Here it's easy for me to know what pi over 2 is. 180 divided by 2 is what? 90. What's 90 times 3? 270 degrees, which is great. If I draw a circle, I'm at 90, 180, there's 270. I'm right here. What is that terminal point?
3 pi over 2.
3 pi over 2.
You had to think about that?
Oh,
No, I thought it was gonna say it wrong.
Okay. So I'm on the y-axis.
Okay, I have absolutely no idea where you just got 270 from.
What is, you understand that pi is 180 degrees? Okay. What is 180 divided by 2? What is 180 divided by 2? 90. So what is 3 times 90? 270. So when we're talking about in terms of pi, we're talking about that unit circle that takes 2 times pi to go all the way around. So we're talking about this distance as we leave the x-axis going counterclockwise all the way around, depending on what that says. Okay? We good with the 270 now? Okay, so let's do another one then. Since you need to know how to, you tell me how to do this. Number 28. No. I'm gonna help you. Again, I want the same thing. I want to know what the terminal point is. Now I could take 5 times 180, but that's really crazy. I'm not very bright. I don't know how to do that. I don't know what that number is. Maybe if I take 5 divided by 3, we'll know that's an ugly fraction. So I can take pi over 3. What is pi divided by 3? 180 divided by 3. How many degrees is that? 180 divided, what's 18 divided by 3? 6. So 180 divided by 3 is 60. Okay? So now we have 5 times 60. What is that value? Stop saying it. What is 5 times 6?
Well, I'm getting a calculator out so I can do the 5 times 60. I don't understand.
Let her do
Why
it.
okay. Like, why me? There's no way you put me on the spot. It's just 300.
Okay, thank you. So that's 300 degrees. And you don't necessarily have to do it this way if you can think about it in terms of pi, but a lot of students have a hard time understanding where we are on the unit circle without degrees. So here's 90, 180, here's 270. How many more do I need? I need 30 more, don't I? Bailey? Yeah. Okay. So this is 30 here. What's my reference? 60. Okay, I want to know what this coordinate is. And the only way to really know that is to understand what my reference angle is. That's a 60-degree triangle. So here's my longer leg, and I have a short leg here. So what is this point? That's why it's important to know the reference angles. It's hard to do this without that. So what is this coordinate? What's the short leg? 1/2. Okay? Yeah, and this is a negative y, negative radical 3 over 2. So tonight's homework is designed to force you to try to learn this stuff. If you consistently use a chart, you're never going to learn it. and you're not gonna do well on the quizzes, and you're not gonna do well on the test. So tonight, make sure you are trying to identify what this is. If you have to use the chart, then definitely use the chart. After the quiz tomorrow, I'm expecting you to use your chart throughout the rest of the chapter. But my hope is that you will get to the point where you won't need it. Okay? All right. I want my reference and my terminal point. Okay? So first of all, what is 4 pi over 3? Let me ask you something. What's pi over 3? 60. What's 4 times 60? 240. You got 4 of them. 240 degrees. 90, 180, and 60 more gives me 4 pi over 3. 60 is my reference angle. What is that in coordinate form? This is my long leg, that's my short leg. Long leg is opposite the 60 degrees. Yeah, the x is -1/2, and negative is radical 3 over 2. So that's your coordinate, your terminal point. I know in the book sometimes it'll say t for that with a slash above it. But what is your reference value in terms of pi? So now I'm asking, what is this in terms of pi? I don't want to know what this is. We already know what this is. This is 4 pi over 3. I want to know this piece right here. It's not positive or negative. If you want to think about it, it's always positive. I don't know what the 60 degree angle is in terms of pi. So it comes down to this. If I'm asking for it in terms of pi, I'm really talking about those 3 values in terms of pi. What were they? degrees, 45 degrees. If you don't know how to do it, this is what you should do. $30 degrees. What's 180? What gives you 30 degrees? 6. 1 over 6. Pi over 6. This reference is going to be pi over 6 for 30. 45 is going to be what? Pi over 4. The reference here for 60 is pi over 3. Boom. That's what this is. That's my reference in terms of pi. Remember, reference refers to how close it is to your x-axis. Positive or negative, it doesn't matter, just make it positive. Okay? If I'm asking for the coordinate, then yeah, you gotta know which quadrant you're in and which x value is positive, which is negative. Okay? So your reference in terms of pi is always going to be one of those 3. Like I said, 150 degrees, this is going to be 30 right here, isn't it? So this reference, the reference, is going to be pi over 6 in terms of pi. Now the coordinates, you know, negative square root of 3 over 2, 1/2. The more you do this, the better you're going to be at it, and there's only certain answers, okay? 45 degrees is always going to be square root of 2 over 2. 30 and 60 is either going to be radical 3 over 2 or 1/2, depending on which one's x and which one's y. There's only 3 possibilities for those numbers. And then you got to decide if it's positive or negative. It's the pi values that's going to be what you got to work at a little bit. Okay? Alright. On the chart tomorrow, for this one, you would put 4 pi over 3. For 240 degrees. Okay? Alright. Suffer through it. It's good for you. Page 375. 3 to 55 odds.